Welcome to Session 4. A missing leg problem looks similar to a hypotenuse problem, but its key operation is subtraction. First, identify the hypotenuse. Then subtract the known leg square from the hypotenuse's square, and take the square root. Today, you will also verify answers and detect impossible data. The hypotenuse is 13, and one leg is 5. The other leg equals the square root of 13 squared minus 5 squared. That is the square root of 169 minus 25, or root 144. The missing leg is 12. When the unknown side is the hypotenuse, add the leg squares. When the hypotenuse is already known and a leg is missing, subtract. Do not decide from the wording alone. Label C first. That single label tells you whether you are building C squared or taking one square away from it. A 10-foot ladder rests against a wall, and its base is 6 feet from the wall. The ladder is the hypotenuse. The height is root 10 squared minus 6 squared, root 100 minus 36, or root 64. The ladder reaches 8 feet up the wall. A 26-foot cable runs from the top of a pole to a point 10 feet from the base. The pole height is root 26 squared minus 10 squared, which is root 576, or 24 feet. Verify. 10 squared plus 24 squared equals 676, the same as 26 squared. A stated hypotenuse must be longer than either leg. If a problem calls 9 the hypotenuse and gives a leg of 12, subtraction produces 81 minus 144, a negative number. No real side length results. That signals that the sides were mislabeled or the data cannot form a right triangle. A right triangle has hypotenuse 25 and one leg 15. The missing leg is root 25 squared minus 15 squared, root 625 minus 225, or root 400. The answer is 20. Check that 15, 20, 25 is a scaled 3, 4, 5 triangle. You can now find a missing leg. Choose subtraction for the right reason and verify the result. Next, we speed up common problems with Pythagorean triples. Visit www.bridgetoexam.com for more GED practice.